Hello everybody, welcome to episode number 3 of the BIVBlog, Benedict's IT video blog. My name is Benedict Stockerbrand and today I want to explain how to come up with a reasonable IPv6 network addressing plan. Now, in the previous episode I already explained how to really screw up by wasting so many addresses that you run out of them by simply encoding things in IP addresses that don't belong there. This time I want to explain how to do this more reasonably. This is focused this time on company or enterprise level networks. So if you watch this and want to figure out how to do it in a home network, you're welcome to watch, and maybe I can give you a couple ideas, but this is not the focus today. Another big mistake you can make when you move from IPv4 to IPv6 is to treat IPv6 as IPv4 with longer addresses. You can do that, it kind of works, but it will make all the problems and limitations of IPv4 move into the IPv6 world with you. And that's not exactly what you want. It's very tempting, especially if you're in a situation that you have little, if any, experience with IPv6. And if you're under time pressure because you need to deploy IPv6 as quickly as possible, for example, because you really need to move to direct access. I've had that with one customer, but it'll cause you a lot of grief in the long run. What you should do is make use of the possibilities and capabilities of IPv6 and really improve your networks that way. The biggest advantage of IPv6 over IPv4 is that it doesn't support broadcast. What it does support instead is multicast, and that's the exciting part, multicast routing. In the IPv4 world, you generally have a situation where applications can tend to interfere with reasonable network topology. At a place I've been working with a couple of years ago, quite a few years ago by now, the office network, which I was not responsible for, but I was using, had about 800 desktop machines in a single subnet because they had two big network printers. Pretty much everybody needed every once in a while, and to make these visible via NetBIOS, we're talking Windows NT4 here, to make them visible via NetBIOS, all the machines had to be in the same subnet as these stupid printers. And this is rather unhealthy. You have that with all sorts of different applications as well, but once you move to IPv6, where the broadcasts are gone, and multicast routing actually works, not only in theory but also in practice, you can move machines into different subnets even if applications need to use multicast between them. And that's a huge win on that. Now, what else can we get rid of? Well, as soon as we don't have applications dictate our link layer topology through the broadcasts, we can get rid of all sorts of workarounds, like bridges, like VPN tunnels, layer 2 tunnels between different buildings in a campus network, where we need to make the same link layer accessible to machines spread all over the place. And what's most important probably is that we can split large networks with lots of machines into more and smaller subnets, which simplifies operations, which makes us much more flexible if you have to move things around, and which helps troubleshooting, and which makes sure that if there are any problems, the effects are more locally restricted. So it really helps to make use of IPv6 with the opportunities it offers. That said, it is currently a huge problem to make IPv6 centric networks when you still have to support IPv4 somehow as well. I know that's a problem, and that's probably the one thing where you really want to put a lot of thought in, so you can run and operate IPv4, but at the same time don't extend the trouble you have from IPv4 into the IPv6 world, even to the time when you finally got rid of most of IPv4 at least. So that's the basic situation where we are. And now, how can we come up with an addressing plan, and to some degree with a network topology? Here's what I suggest. So what makes a good address plan? A good address plan and a good network architecture as well is simple. So it's easy to keep a mental overview of it, and with limited components, whatever, so there are a few things that can actually break. And it's organized around a couple of rules we come up with, and with very few exceptions to these rules or guidelines or whatever, because every exception increases complexity and makes trouble when troubleshooting. So that's the way we want to go. And for a transition period, we have yet another problem, which is that we have to somehow get IPv4 and IPv6 to run on the same network. And that's actually rather painful. And how to do that is frequently very difficult to explain in a more general context. You want to put a lot of thought in there during migration of your particular network. Okay, so how do we start with our address plan? First, assume that for a moment you are either an LIR, a local IP registry, or you have PI addresses, provider independent addresses, and multiple locations to deal with. If you don't have that, fine, just fast forward a bit and see how to deal with your probably /48 you've got from your ISP. But if you're your own ISP, if you are your own LIR, if you have PI addresses, you want to allocate them properly to multiple locations. Now, the goal you have here, which is very important, is to make sure that for every location you only distribute one route to the default free zone, to the place where the routers don't have a default route, the big carrier places. Why is that? Because the big routers there implement IPv6 routing in hardware, and every extra route costs significant money. These routers are expensive and they only have limited amount of address space. Now you might argue, yeah, but that's not my money, so why should I care? Because in the IPv4 world, there's already a number of carriers who drop routes which are excessive. And you run into that problem, all of a sudden your network connectivity won't work properly, and then you do have a problem. So what I strongly suggest, for every site, deploy at least a 48-bit prefix, nothing longer, because if you go for anything longer than a 48-bit prefix, there's a good chance that carriers will eventually drop your routes. And then you start to work around that with more specific, make them more specific routes to a general route, and start to tunnel things and blah 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 blah. That's just unnecessarily painful and violates the simplicity and ease of operation goals we have. At this point, the distinction between multi-site enterprise with PI addresses or LIR status becomes unnecessary, and we can continue to deal with both a single site from such an enterprise or a single site company using the same approach again. Now, the first thing you want to do is make sure that if you have a backbone with multiple routers, that you want to keep the routing table entries there reasonably small. Same reasoning as with the LRR or PI address range applies here, except that this time it's not affecting other people's routers but your own. And how to do that depends on your particular network topology, so I can't say very much about that. Just what you want to be aware of is you will need addresses or subnets for purposes you can't even imagine at this point in time. So on one hand, leave space to grow within your sub-allocations. On the other hand, make sure you have some spare left because you're going to need it. And in small environments, there's possibly another trick you can do. It frequently doesn't work, but if it does, it may be quite useful to you, and that's to keep the subnet ID as a string the same as to the VLAN IDs you use in the link layer. If that's possible, it simplifies life again. Otherwise, okay, you'll have to do without that. At that point, you can simply allocate subnet IDs to individual subnets and you're pretty much finished. Except for a few things you want to keep in mind. There are a couple of special subnet IDs that I recommend to use for specific purposes. Subnet ID 0 may be used by your upstream ISP to connect between their access router and your CPE or CER router. CPE is customer premises equipment and CER is customer edge router. So basically for the subnet between their routers and yours. I suggest you don't use that. Subnet IDs 1, 2 and 3 I would reserve for name servers. Even if you only have a single name server right now, I suggest reserve 3 different subnets, so if you grow and decide you want more name servers for redundancy reasons, then you have these subnets defined in such a way that you can easily remember them. And if you use this subnet ID VLAN ID match, then you also don't want to use VLAN IDs 0 and 1 because they generally have different specific meaning anyway. So it makes sense to use one for the router where you don't, or for your uplink, so you don't use a VLAN there, quite likely anyway, and the other one for a name server which you want to may have able to move around. So much for allocating addresses down to the subnet prefix length. Next time I'll explain how to come up with the interface ID part of addresses, because there are a couple more things to say about that as well. Until then, I hope you enjoyed this. If you want to discuss or want to take a look at whatever references I have, I don't think I have any this time, move over to the forum. And anyway, hopefully see you next time. See you soon. Bye.